ಪ್ರಾಬ್ಲಮ್ಸ್ ಆನ್ ದ ಆಟಮ್ಸ್. ಇಷ್ಟು ಪ್ರಾಬ್ಲಮ್ನ ನೀವು ಕರೆಕ್ಟಾಗಿ ನೋಡ್ಕೊಳ್ಳಿ. ಫಸ್ಟ್ ಪ್ರಾಬ್ಲಮ್ ಏನ್ ಹೇಳುತ್ತೆ? ಫೈಂಡ್ ದ ವೇವ್ ಲೆಂತ್ ಆಫ್ ದ ಫಸ್ಟ್ ಲೈನ್ ಆಫ್ ದ ಲೈಮನ್ ಸೀರೀಸ್ ಅಂಡ್ ಫಸ್ಟ್ ಲೈನ್ ಆಫ್ ದ ಬಾಮರ್ ಸೀರೀಸ್. ಅರ್ಥ ಆಯ್ತಾ? ಇವಾಗ ನೋಡಿ, ಈ ಕೊಟ್ಟಾಗ ನೀವೇನ್ ಮಾಡಬೇಕು? ಫಸ್ಟಿಗೆ ಯು ಶುಡ್ ರೈಟ್ ಅನ್ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಫಾರ್ ದ ವೇವ್ ನಂಬರ್. an expression for the wave number. Nu bar is equal to r into 1 over n1 square minus 1 over n2 square. Remember, ನೀವು ಕೇಳಿರೋದು ಫಸ್ಟ್ ಲೈನ್ ಆಫ್ ದ Lyman C and he has given the value of r. He has given, okay, value of the r has been given to be 1.097 into 10 to the power of 7 per meter. ಇವಾಗ ಯಾವ್ದು ಬೇಕು? ಫಸ್ಟ್ ಲೈನ್ ಆಫ್ ದ ಬಾಮರ್ ಸೀರೀಸ್. Okay, for first line of the Lyman series, first line of the Lyman series, you write the put your n1 is equal to 1 and n2 is equal to 2. Therefore, your nu bar is equal to, so r into 1 over 1 square minus 1 over 2 square. ಈಗ ಇಷ್ಟೊತ್ತಿಗಾಗಲೇ ಬೈಹರ್ಟ್ ಆಗಿರಬೇಕು ನಿಮಗೆ. 1 by lambda r into 1 minus 1 by 4. You know that this comes out to be equal to 3 by 4r. Therefore, your lambda is equal to 4 by 3r. Now you substitute for this one. 4 by 3 into 1 by value of r is equal to 1.097 into 10 to the power of 7. Always you try to remember the value of 1.097, which would be helpful for you always, because in all this expression you will get s and r in the denominator. You try to take the reciprocal of this 0.911. Okay, if you multiply this 0.911 by this one, you will get 1.215 into 10 to the power of minus 7 meter. That's all. Okay, and this is the wavelength of the first line of the Lyman series. Remember this. That you can convert it into the angstroms as 1215 angstroms. 1215 ಸರ್ ಹೆಂಗ್ ಬರುತ್ತೆ ಅಂತ ಡೌಟ್ ಇರುತ್ತೆ. ಈ 215 ಈ ಕಡೆ ತಗೊಂಡ್ರೆ 3 zeros ಎಕ್ಸ್ಟ್ರಾ ಬರುತ್ತೆ. ಸೊ -7 plus -3, so it's equal to -10, which is an angstroms. ಅರ್ಥ ಆಯ್ತಾ? 1215 angstroms appears in the UV region, because you know that UV region has a wavelength ranging from 100 to 4000 angstroms. Okay, ಇದು ನೋಡಿ ಎಷ್ಟಿದೆ? ಇದು 1215 ಗೆ ಬರುತ್ತೆ. ಅಂದ್ರೆ ಇದು it is in the UV region. You make an habit to write 1215 angstroms. It appears in the UV region ಅಂತ ತಲೆಯಲ್ಲಿ ಫಿಕ್ಸ್ ಆಗುತ್ತೆ ಐಡಿಯಾ. ಇವಾಗ ಎರಡನೇದು ಬನ್ನಿ. ಯಾವ್ದಕ್ಕಪ್ಪ? ಫಾರ್ the first line of Balmer series. First line of the Balmer series. Put n1 is equal to 2 and n2 is equal to 3. ನಿಮಗೆ ಗೊತ್ತಿದೆ H alpha line. ಅವಾಗ ಈ ಫಾರ್ಮುಲಾ ಏನಾಗುತ್ತೆ? nu bar is equal to r into 1 over 2 square minus 1 over 3 square. And this is 1 by lambda. ಇದನ್ನ ನೀವು H alpha ಅಂತ ಬರ್ಕೊಳ್ಳಿ. ಯಾಕಂದ್ರೆ ಫಸ್ಟ್ ಲೈನ್ ಇಸ್ ಕಾಲ್ಡ್ as an H alpha, r into 1 by 4 minus 1 by 9, and therefore 1 by lambda H alpha is equal to r into 5 by 36. ಚೆನ್ನಾಗಿ ಜ್ಞಾಪಕ ಇರಬೇಕು. Therefore your lambda H alpha is equal to 36 by 5r. So you substitute 36 by 5 into 1 by value of r is equal to, you know that 1.097 into 10 to the power of 7, and that 36 by 5 into 0.911 into 10 to the power of minus 7. If you simplify these things, this comes out to be 6.563 into 10 to the power of minus 7 meter. ನಿಮ್ಗೆ ಇಲ್ಲಿಗೆ ಸಾಕು. ಆಕ್ಚುಲಿ ಇಲ್ಲಿಗೆ ಇಷ್ಟು ಬರ್ದ್ರೇನೆ ಸಾಕು. ಬಟ್ ಆಲ್ವೇಸ್ ವಿ ಪುಟ್ ದ ವೇವ್ ಲೆಂತ್ ಇನ್ ಆಂಗ್ಸ್ಟ್ರಾಮ್ಸ್ ಅಲ್ಲಿ ಇಡ್ತೀವಿ ನಾವು ಯಾವಾಗ್ಲೂ ಕೂಡ. ಅರ್ಥ ಆಯ್ತಾ? ಅದಕ್ಕೆ ಏನ್ ಮಾಡೋಣ, ಒಂದು ಸ್ಟೆಪ್ ಎಕ್ಸ್ಟ್ರಾ ಬರೆಯೋಣ. ಏನಪ್ಪ, ಲ್ಯಾಂಬ್ಡಾ ಹೆಚ್ ಆಲ್ಫಾ 6563 ಆಂಗ್ಸ್ಟ್ರಾಮ್ಸ್ ಅಂತ. ಓಕೆ, ಬಹಳ ಇಂಪಾರ್ಟೆಂಟ್. 6563 ಅಂತಂದ್ರೆ ಹೆಚ್ ಆಲ್ಫಾ ಲೈನ್ ಅಂದ್ರೆ ಇದು 6600 ಹತ್ರ ಇದೆ ಅಂದ್ರೆ ಇಟ್ಸ್ ಆಲ್ಮೋಸ್ಟ್ ರೆಡ್ ಬರುತ್ತೆ, ಆಲ್ಮೋಸ್ಟ್ ರೆಡ್ ಲೈನ್. ದೇರ್ಫೋರ್ ರೆಡ್ ಕಣ್ಣಿಗೆ ಕಾಣಿಸುತ್ತೆ ಅಲ್ವಾ, ವಿಸಿಬಲ್ ರೀಜನ್ ಅಲ್ಲಿ ಬರುತ್ತೆ ಅಲ್ವಾ. ಆಮೇಲೆ ನೋಡಿ, ನಿಮ್ಗೆ ಗೊತ್ತಿದೆ ವಿಸಿಬಲ್ ರೀಜನ್ ಅಪಿಯರ್ಸ್ ಫ್ರಮ್ 4000 to 8000 ಆಂಗ್ಸ್ಟ್ರಾಮ್ಸ್ ಅಲ್ವಾ. ಸೊ ಕಣ್ಣಿಗೆ ಕಾಣಿಸುತ್ತೆ ವಿಸಿಬಲ್ ಅಂದ್ರೆ, ಇದು ನೋಡು ಕಣ್ಣಿಗೆ ಕಾಣಿಸುತ್ತೆ ಅಂದ್ರೆ ನೀವು ಪ್ರಾಬ್ಲಮ್ ಮಾಡಿದಾಗ ಇವೆಲ್ಲ ಕನ್ಕ್ಲೂಷನ್ ಬರೆದು ಇಟ್ಕೊಂಡಿರ್ಬೇಕು. ಎಸ್, ಇಟ್ ಅಪಿಯರ್ಸ್ ಇನ್ ದ ವಿಸಿಬಲ್ ರೀಜನ್. ಲೈಮನ್ ಸೀರೀಸ್ ಅಪಿಯರ್ಸ್ ಇನ್ ದ ಯುವಿ ರೀಜನ್. ಅವಾಗ ನಿಮ್ ತಲೆಯಲ್ಲಿ ಫಿಕ್ಸ್ ಆಗುತ್ತೆ. ಎಕ್ಸಾಮ್ ಹಿಂದಿನ ದಿವಸ ಚೂರು ಪ್ರಿಪೇರ್ ಮಾಡೋದು, ಅಯ್ಯೋ ಯಾವ ಸೀರೀಸು ಇದು ಯಾವ ಸೀರೀಸ್, ಇಲ್ಲಿ ಮೊದಲೇ ರೆಡಿ ಮಾಡ್ಕೊಂಡಿರ್ಬೇಕು. ಅರ್ಥ ಆಯ್ತಾ? ಇಟ್ಸ್ ಅ ಪ್ರಾಬ್ಲಮ್ ನಂಬರ್ 1. ಈಗ ಎರಡನೇ ಪ್ರಾಬ್ಲಮಿಗೆ ಬನ್ನಿ ಕೇರ್ಫುಲಿ. ಗಿವನ್ ದ ವೇವ್ ಲೆಂತ್ ಆಫ್ ದ ಫಸ್ಟ್ ಲೈನ್ ಆಫ್ ದ ಬಾಮರ್ ಸೀರೀಸ್ ಟು ಬಿ 6563 ಆಂಗ್ಸ್ಟ್ರಾಮ್ಸ್, ಫೈಂಡ್ ದ ವೇವ್ ಲೆಂತ್ ಆಫ್ ದ ಫಸ್ಟ್ ಲೈನ್ ಆಫ್ ದ ಲೈಮನ್ ಸೀರೀಸ್. ಅರ್ಥ ಆಯ್ತಾ ಪ್ರಾಬ್ಲಮ್ ಇದು? ಸೊ ಏನ್ ಕೇಳ್ತಾ ಇದ್ದಾರೆ ಅವನು, ಪ್ರಾಬ್ಲಮ್ ಏನ್ ಕೇಳ್ತಾ ಇದ್ದಾನೆ ಅಂತ ಅಂದ್ರೆ, ಸೊ ಇನ್ ದ ಪ್ರಾಬ್ಲಮ್ ನಂಬರ್ 2 he has given that the wavelength of the H alpha line to be 6563 angstroms. Find the wavelength of the first line of the Lyman series. First line of the Lyman series. Okay, lambda you have to calculate. He has not given anything, no R and R. ಇವಾಗ ಏನ್ ಮಾಡಬೇಕು, ಈ ಫಾರ್ಮುಲಾ ಬರೀಬೇಕು. ಅದಾದ್ಮೇಲೆ ಫಾರ್ ದ ಫಸ್ಟ್ ಲೈನ್ ಆದ ಲೈಮನ್ ಸೀರೀಸ್ ಈಕ್ವೇಶನ್ ತಗೋಬೇಕು. ದಿಸ್ ಇಸ್ ಈಕ್ವೇಶನ್ ನಂಬರ್ 1. ಜ್ಞಾಪಕ ಇಟ್ಕೊಳ್ಳಿ, ಡೈರೆಕ್ಟ್ ಆಗಿ ಇದನ್ನು ಬರೀಬಾರ್ದು, ನೀವು ಹಿಂಗೆ ಬರ್ಕೊಂಡ್ರೆ ಬರಬೇಕು. ಇದು ಈಕ್ವೇಶನ್ ನಂಬರ್ 2. ಅರ್ಥ ಆಯ್ತಾ? ಹಿ ಹ್ಯಾಸ್ ಗಿವನ್ ದಿಸ್ ಲ್ಯಾಂಬ್ಡಾ ಹೆಚ್ ಆಲ್ಫಾ ಅಂಡ್ ಹಿ ಹ್ಯಾಸ್ ಆಸ್ಕ್ಡ್ ಯು ಟು ಕ್ಯಾಲ್ಕುಲೇಟ್ ದಿಸ್ ಲ್ಯಾಂಬ್ಡಾ. ಏನ್ ಮಾಡ್ತೀರಾ ಅವಾಗ, ಡಿವೈಡ್ 1 by the other. Divide equation 1 and 2. So when you divide equation 1 and 2, divide equation 1 and 2, ಅವಾಗ ಏನಾಗುತ್ತೆ, lambda by lambda h alpha is equal to, so your lambda is equal to 4 by 3r and this is equal to 36 by 5r. You know that r and r get cancelled. So ನಿಮಗೆ ಇಲ್ಲಿ ಏನು ಉಳಿಯುತ್ತೆ, 4 by 3 ಈ ಕಡೆ ಉಳಿಯುತ್ತೆ, ಇದು 5 by 36 ಉಳಿಯುತ್ತೆ. 9 36. ಅರ್ಥ ಆಯ್ತಾ? ಸೊ therefore what you are left with is 5 by 27. ನಿನಗೇನು ಬೇಕು ಇವಾಗ, ಲ್ಯಾಂಬ್ಡಾ ಬೇಕು. ಸೊ ಇವಾಗ 5 by 27 into lambda h alpha and therefore 5 by 27 lambda h alpha is 6563 angstroms. This is also wavelength that comes in angstroms. So therefore 5 into 27 ಇಂದ ಡಿವೈಡ್ ಮಾಡಿ, 27 2s is 54. ಅರ್ಥ ಆಯ್ತಾ? then 16 ಉಳಿಯುತ್ತೆ. Okay, so therefore so it is 54 and you are left with 116. 27 4s is 108. ಗೊತ್ತಲ್ವಾ? ಆಮೇಲೆ 8 ಉಳಿಯುತ್ತೆ 83 and 27 3s is 81. Therefore this if you multiply, this comes out to be 1215 angstroms. That's all the wavelength of the first line of wavelength of the first line of the Lyman series. These are all important varieties. When one line is given, other line is to be calculated. This is a technique and R get cancelled. ಅರ್ಥ ಆಯ್ತು? ಅದಕ್ಕೋಸ್ಕರ R ಕೊಟ್ಟಿರಲ್ಲ ಇಲ್ಲಿ. ಇದು ಬಹಳ ಇಂಪಾರ್ಟೆಂಟ್. ಅವಾಗ ನೀವೇನ್ ಮಾಡಬೇಕು, you should write the wavelength of the first line, wavelength of the second line, and whichever the line he has given, and then you divide 1 by the other. Did you follow this? Okay. Question number 3, carefully. What he has said, given the wavelength of the first line of the Lyman series to be 1215 angstroms, find the wavelength of H alpha line, H beta line, H gamma line, H delta line. You have to calculate the wavelength of 4 different lines. Okay? The equations are very simple. First you should write the formula. What is the formula for nu bar? R into 1 over n1 square minus 1 over n2 square is a formula. He has given the value of lambda. That's the first line of the Lyman series. So you get the equation for the first line of the Lyman series like this. Then you get the equation for the second line of the Lyman series, because he wants that H alpha. So this is H alpha. Then for second line of Balmer series, or which we call it as an H beta, put your N1 is equal to 2 and N2 is equal to 4, because you must remember this one. You remember that H beta is equal to, H beta is equal to, it's a second line, 4 to 2. That means N1 is equal to 2 and N2 is equal to 4. You substitute in that expression, your new H beta is equal to R into 1 over 2 square minus 1 over 4 square. That comes out to be R into, so you know that 1 by 4 is a common factor, you are left with, so it is equal to 1 minus 1 by 4. Okay, 1 by 4 minus 1 by 16, that is equal to, and your R by 4 into, and this comes out to be 3 by 4. And therefore, your 1 by lambda H beta is equal to, okay, so your formula is equal to, so it is equal to 3R divided by 16. Therefore, lambda H beta is equal to 16 by 3R. Remember, take it as equation number 3. Okay. Similarly, you write the equation for lambda H gamma. H gamma means third line. And then the fourth line also I have asked. That's called as a H delta line, we call it as. H alpha, H beta, H gamma and H delta line. You add that fourth one also, H delta line. So you want to calculate the H delta line. So like this you take equation 1, equation 2, equation 3. For H gamma equation 4, for H delta equation 5. Okay. Now what you do? You divide one by the other. Okay. You divide one by the other. That means you want this H alpha, divide by equation number 1. Therefore, your lambda H alpha you want, and divided by lambda. Lambda H alpha is given by 36 by 5R divided by lambda is equal to 4 by 3R. So you know that RR get cancelled. And this value is equal to 36 by 4 into 3 by 5. So therefore 4 ones are, 4 nines are. And that comes out to be equal to, so this is equal to 27 divided by 5. Therefore, your lambda H alpha is equal to 27 by 5 multiplied by, so it is equal to lambda 1. Therefore, you substitute this one, 27 by 5 into value of this lambda is equal to 1215 angstroms. Okay, 1215 angstroms. Then, so you simplify this. So if you simplify that, 27 by 5, remember, so it is 27 by 5 and you are multiplying by 1215 angstroms, which comes out to be 6563 angstroms. It is 6563 angstroms. Lambda H alpha. Okay? So now what you do? You have divided equation 2 and 1. Now you divide equation 3 and 1. Okay. Divide equation 3 and 1. ಏನಾಗುತ್ತೆ ಅವಾಗ? Your lambda H beta is equal to lambda H beta divided by lambda. Lambda H beta you have written it as a 16 by 3R whole divided by, that value is equal to 4 by 3R. Your 3R get cancelled. Therefore this is equal to 4 ones are, 4 fours are, it's equal to 4. Therefore your lambda H beta is equal to 4 into lambda. And that comes out to be equal to 4 into 1215 angstroms. Okay. Now you simplify that value. So that's equal to 1215 into 4 comes out to be 4860. Therefore, your lambda H beta is equal to 4860 angstroms. Did you follow this? ಅದೇ ತರನೇ you get it for H delta. H gamma is the third line. H delta. Remember wavelength of H gamma. H gamma is the third line. Next is H delta. H delta. Delta you like this. So therefore that you calculate. That you take it as a home assignment and you calculate that. You know why I calculated all these things is, remember, you know the conclusion from this one? ಸರ್ ಯಾತಕ್ಕೆ ನೀವು ಈ ಥರದನ್ನ ಡಿವೈಡ್ ಮಾಡಿದ್ರಿ, ಈ ಥರದ್ದೆಲ್ಲ ಯಾಕೆ ಬೇಕು ನಮಗೆ ಅಂತ ಕೇಳಿದ್ರೆ, ರಿಮೆಂಬರ್ ಲ್ಯಾಂಡಾ ಹೆಚ್ ಆಲ್ಫಾ ಇದೆಯಲ್ಲ, ಇದ್ರದ್ದು ವೇವ್ ಲೆಂತ್ ಎಷ್ಟಾಯ್ತು? 6563 ಆಂಗ್ಸ್ಟ್ರಾಮ್ಸ್ ಆಯ್ತು, ವಿಚ್ ವಿ ಹ್ಯಾವ್ ಕ್ಯಾಲ್ಕುಲೇಟೆಡ್, ವಿಚ್ ಇಸ್ ದ ಫಸ್ಟ್ ಲೈನ್. ವಾಟ್ಸ್ ದ ವೇವ್ ಲೆಂತ್ ಆಫ್ ದ ಸೆಕೆಂಡ್ ಲೈನ್? ಲ್ಯಾಂಡಾ ಹೆಚ್ ಬೀಟಾ, ವಿಚ್ ಇಸ್ 4860 ಆಂಗ್ಸ್ಟ್ರಾಮ್ಸ್. It is the second line. Look here, second line. ಸ್ವಲ್ಪ ಯೋಚನೆ ಮಾಡಿ ಇದೆಲ್ಲ ಬಂದಾಗ. ಏನು ಯೋಚನೆ ಮಾಡಬೇಕು ಅಂತ ಅಂದ್ರೆ, ಯುವರ್ E is equal to H nu by that's equal to Hc by lambda ಅಂದ್ರೆ ಏನು ಅರ್ಥ ಆಯ್ತು ಗೊತ್ತಾ? ಇಲ್ಲಿ ನೋಡಿ, ಇದು ವೇವ್ ಲೆಂತ್ ಕಡಿಮೆ. ವೇವ್ ಲೆಂತ್ ಕಡಿಮೆ ಅಂದ್ರೆ ಫ್ರೀಕ್ವೆನ್ಸಿ ಜಾಸ್ತಿ, ಅಂದ್ರೆ ಎನರ್ಜಿ ಗ್ಯಾಪ್ ಜಾಸ್ತಿ. ನೋಡಿ ಇಲ್ಲಿ ಎನರ್ಜಿ ಗ್ಯಾಪ್ ಜಾಸ್ತಿ, ಎನರ್ಜಿ ಗ್ಯಾಪ್ ಜಾಸ್ತಿ ಇಲ್ಲಿ. ನೋಡಿ ಎನರ್ಜಿ ಗ್ಯಾಪ್ ಕಡಿಮೆ, ಎನರ್ಜಿ ಗ್ಯಾಪ್ ಇಸ್ ಲೆಸ್, ಫ್ರೀಕ್ವೆನ್ಸಿ ಇಸ್ ಲೆಸ್, ವೇವ್ ಲೆಂತ್ ಇಸ್ ಮೋರ್. ನೋಡಿ ವೇವ್ ಲೆಂತ್ ಇಸ್ ಮೋರ್. ಅರ್ಥ ಆಯ್ತಾ? ಓಹೋ ಅಂದ್ರೆ ಏನರ್ಥ? ಇಫ್ ಯು ಟೇಕ್ ಎನಿ ಸೀರೀಸ್ ಹಿಯರ್, ಲೈಮರ್ ಆರ್ ಬಾಮರ್ ಆರ್ ಪ್ಯಾಷನ್ ಆರ್ ಎನಿ ಸೀರೀಸ್, ಯು ಹ್ಯಾವ್ ಟು ಮೇಕ್ ಎ ನೋಟ್. ಏನಪ್ಪ ನೋಟ್ ಏನ್ ಮಾಡ್ತೀರಾ? ಫಸ್ಟ್ ಲೈನ್ ಆಫ್ ದ ಸೀರೀಸ್, ಫಸ್ಟ್ ಲೈನ್ ಆಫ್ ದ ಸೀರೀಸ್ has the longest wavelength. ಬಹಳ ಇಂಪಾರ್ಟೆಂಟ್ ಇದೆ, ಈ ಕನ್ಕ್ಲೂಷನ್ ಗೊತ್ತಿರಬೇಕು. has the longest wavelength. ನೋಡಿ ಯಾವುದೇ ಸೀರೀಸ್ ತಗೊಳ್ಳಿ, ಫಸ್ಟ್ ಲೈನ್ ಇರುತ್ತಲ್ಲ ಲಾಂಗೆಸ್ಟ್ ವೇವ್ ಲೆಂತ್, ಸೆಕೆಂಡ್ ಲೈನಿಗೆ ವೇವ್ ಲೆಂತ್ ಕಡಿಮೆ ಆಗುತ್ತೆ, ಥರ್ಡ್ ಲೈನಿಗೆ ವೇವ್ ಲೆಂತ್ ಇನ್ನೂ ಕಡಿಮೆ ಆಗುತ್ತೆ, ಫೋರ್ತ್ ಲೈನಿಗೆ ವೇವ್ ಲೆಂತ್ ಕಡಿಮೆ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. ಜ್ಞಾಪಕ ಇರಬೇಕು. ಅದರಿಂದ ಕನ್ಕ್ಲೂಷನ್ ಬರೀಬೇಕು. ಸಬ್ಸಿಕ್ವೆಂಟ್ ಲೈನ್ಸ್ have decreased wavelength. Conclusion ಬರೆದಿಟ್ಕೊಂಡಿರಿ, have decreased wavelength. ಬಹಳ ಇಂಪಾರ್ಟೆಂಟ್ ಅದು, ಅರ್ಥ ಆಯ್ತಾ? ಅದರಿಂದ ಯಾವುದೇ ಸೀರೀಸ್ ತಗೊಳಪ್ಪ, ಲೈಮನ್ ತಗೊಂಡ್ರೆ ಇದಕ್ಕೆ ಲಾಂಗೆಸ್ಟ್ ವೇವ್ ಲೆಂತ್, ಇದ್ರ ವೇವ್ ಲೆಂತ್ ನೋಡಿ ನೀವು ಇಲ್ಲಿ ಚೆನ್ನಾಗಿ ಜ್ಞಾಪಕ ಇರಬೇಕು. ನೋಡಿ ಹಿಂಗೆ ನೋಡಿ, ಗ್ಯಾಪ್ ಕಡಿಮೆ, ಎನರ್ಜಿ ಡಿಫರೆನ್ಸ್ ಕಡಿಮೆ, ಇಲ್ಲಿ ಈ ಕ್ವಶನ್ ತಲೆ ಇರಬೇಕು. ಎನರ್ಜಿ ಡಿಫರೆನ್ಸ್ ಕಡಿಮೆ, ಫ್ರೀಕ್ವೆನ್ಸಿ ಕಡಿಮೆ, ವೇವ್ ಲೆಂತ್ ನೋಡಿ ಜಾಸ್ತಿ. ನೆಕ್ಸ್ಟ್ ಬನ್ನಿ ನೋಡಿ, ಗ್ಯಾಪ್ ಜಾಸ್ತಿ, ಎನರ್ಜಿ ಜಾಸ್ತಿ, ಫ್ರೀಕ್ವೆನ್ಸಿ ಜಾಸ್ತಿ, ವೇವ್ ಲೆಂತ್ ಕಡಿಮೆ. ನೋಡಿ ವೇವ್ ಲೆಂತ್ ಕಡಿಮೆ. ಮೂರನೇ ಬನ್ನಿ ನೋಡಿ, ಎನರ್ಜಿ ಇಷ್ಟು, ಓ ಎನರ್ಜಿ ಜಾಸ್ತಿ, ಫ್ರೀಕ್ವೆನ್ಸಿ ಜಾಸ್ತಿ, ವೇವ್ ಲೆಂತ್ ನೋಡಿ ಇನ್ನೂ ಕಡಿಮೆ, 4360 ಬರುತ್ತೆ. ನೋಡಿ ಈ ಲೈನ್ ತಗೊಳ್ಳಿ, ಇನ್ನೂ ಎನರ್ಜಿ ಗ್ಯಾಪ್ ಜಾಸ್ತಿ, ಫ್ರೀಕ್ವೆನ್ಸಿ ಜಾಸ್ತಿ, ವೇವ್ ಲೆಂತ್ ಕಡಿಮೆ. ಸರ್ ಶಾರ್ಟೆಸ್ಟ್ ವೇವ್ ಲೆಂತ್ ಯಾವ್ದು ಬರುತ್ತೆ ಅಂತಂದ್ರೆ, ಚೆನ್ನಾಗಿ ಜ್ಞಾಪಕ ಆಗಲಿ, ಈ n is equal to infinity ಬಂದಾಗ ಶಾರ್ಟೆಸ್ಟ್ ವೇವ್ ಲೆಂತ್. ಓಹೋ ಅಂದ್ರೆ ಈ ವೇವ್ ಲೆಂತ್ ಕಡಿಮೆ ಆಗಿ ಶಾರ್ಟೆಸ್ಟ್ ವೇವ್ ಲೆಂತ್ ಬರ್ಬೇಕಾದ್ರೆ ಎಲೆಕ್ಟ್ರಾನ್ ಎಲ್ಲಿಂದ ಜಂಪ್ ಹೊಡಿಬೇಕು? n2 is equal to infinity ಇಂದ ಅಲ್ಲಿ ಜಂಪ್ ಹೊಡೆದ್ರೆ you will get the shortest wavelength. ಅರ್ಥ ಆಯ್ತಾ? ಸೊ ಇದು ಕನ್ಕ್ಲೂಷನ್. ಅದಕ್ಕೆ ಕನ್ಕ್ಲೂಷನ್ ಏನು ಕೇಳಿದ್ರೆ, ಫಸ್ಟ್ ಲೈನ್ ಬರ್ದಿಟ್ಕೊಂಡಿರ್ಬೇಕು. ಫಸ್ಟ್ ಲೈನ್ ಬರ್ದಿಟ್ಕೊಳ್ಳಿ, ಅದನ್ನ ಪದೇ ಮತ್ಕೊನೆ ಮರ್ತ್ಬಿಟ್ಟಿರಾ. ಫಸ್ಟ್ ಲೈನ್ ಆಫ್ ದ ಸೀರೀಸ್ ಹ್ಯಾಸ್ ದ ಲಾಂಗೆಸ್ಟ್ ವೇವ್ ಲೆಂತ್. First line of the series has the longest wavelength. The wavelength of the subsequent lines decreases. Wavelength of the subsequent line decreases. Aita? And we get shortest wavelength. We get shortest wavelength when electron jumps from n is equal to infinity level. Ready? We get shortest wavelength. We get shortest wavelength when electron jumps from ಯಾವ ಲೆವೆಲ್? ಇನ್ಫಿನಿಟಿ ಲೆವೆಲ್. ಆ ಶಾರ್ಟೆಸ್ಟ್ ವೇವ್ಲೆಂತ್ ಅಂತ ಹೇಳೋ ಬದಲಾಗಿ ಸೀರೀಸ್ ಲಿಮಿಟ್ ಅಂತಾನು ಹೇಳ್ತಾರೆ. ಫೈಂಡ್ ದ ವೇವ್ಲೆಂತ್ ಆಫ್ ಸೀರೀಸ್ ಲಿಮಿಟ್. ಸೀರೀಸ್ ಲಿಮಿಟ್ ಅಂದ್ರೆ ಗಾಬರಿ ಆಗಬೇಡಿ, ಶಾರ್ಟೆಸ್ಟ್ ವೇವ್ಲೆಂತ್ ಅಂತ. ಓಕೆ, now we shall take up the problem number 4. Longest and the shortest wavelength of the Lyman series. find the question number 4. The longest wavelength under first line, longest wavelength, and the shortest wavelength. Shortest wavelength under that we call it as a, we denote it as a lambda infinity ಅಂತ ಬರ್ಕೊಳ್ಳಿ. ಅಲ್ಲೇ ನಿಮ್ಗೆ ಒಂದು ಅರ್ಥ ಗೊತ್ತಾಗ್ಬಿಡ್ಬೇಕು ಹೆಂಗೆ ಇನ್ಫಿನಿಟಿ ಲೆವೆಲ್ ಇಂದ ಬರುತ್ತೆ ಅಂತ. And he has given the value of R as 1.097 10 to the power of 7 per meter. ಅರ್ಥ ಆಯ್ತಾ? ಅವಾಗ ಈ ಫಾರ್ಮುಲಾ ಬರೀರಿ. ಫಸ್ಟ್ ಈ ಫಾರ್ಮುಲಾ ಬರೀರಿ. ರೈಟ್ ದ ಫಾರ್ಮುಲಾ. ಫಾರ್ಮುಲಾ ಬರೆದ್ರಲ್ವಾ? ಈಗ ಒಂದು ಲೈನ್ ಬರೀರಿ. ಏನಂತ ಬರೀತೀರಾ? First line of the Lyman series has the longest wavelength. ಬರೀರಿ ಒಂದು ಲೈನ್. First line of the Lyman series has the longest wavelength. Okay. First line of the Lyman series has the longest wavelength ಅಂತ ಬರೆದ್ರಾ? ಈಗ ಬರೀರಿ. Put n1 is equal to 1 and n2 is equal to 2 ಅಂತ ಬರೆದು ಫುಲ್ ಈಕ್ವೇಶನ್ ಅನ್ನು ರಿಪೀಟ್ ಮಾಡಿ. ಅವಾಗ 4/3 into 1/1.097 into 10 to the power of 7. You know that 4/3 is the value 0.911 into 10 to the power of -7 meter. So ಇದಿಷ್ಟು ವರ್ಕೌಟ್ ಮಾಡಿದ್ರೆ 1.215 into 10 to the power of -7 meter. ಅಷ್ಟೇ. ಆಯ್ತಾ? ಯಾವಾಗಲೂ ನಿಮಗೆ ನಾವು ಹೇಳ್ತಾ ಇದ್ವಿ ಅಲ್ವಾ, ಇದನ್ನ ಆಂಗ್ಸ್ಟ್ರಾಮ್ಸ್ ನಲ್ಲಿ ಇಡ್ತೀವಲ್ಲ. ಸೊ ಯು ರೈಟ್ ಲ್ಯಾಂಬ್ಡಾ ಇಸ್ ಈಕ್ವಲ್ ಟು 1215 ಆಂಗ್ಸ್ಟ್ರಾಮ್ಸ್. ಓಕೆ, ಬರ್ದ್ರ ಇದನ್ನ? ಈಗ ಬರೀರಿ. ವಿ ಗೆಟ್ ಶಾರ್ಟೆಸ್ಟ್ ವೇವ್ಲೆಂತ್, ವಿ ಗೆಟ್ ಶಾರ್ಟೆಸ್ಟ್ ವೇವ್ಲೆಂತ್, ಶಾರ್ಟೆಸ್ಟ್ ವೇವ್ಲೆಂತ್ in Lyman series. We get shortest wavelength in Lyman series when electron jumps from, when electron jumps from ಎಲ್ಲಿಂದ? So n is equal to infinity to n is equal to 1. That you can write n2 is equal to infinity to, n2 is equal to infinity to n1 is equal to 1. ಸೊ ಇವಾಗ ಫಾರ್ಮುಲಾನ ಬರೀರಿ. ಏನ್ ಫಾರ್ಮುಲಾ ಬರೀತೀರಾ ಇವಾಗ? ಯುವರ್ ನ್ಯೂ ಬಾರ್ ದಟ್ ಯು ಕಾಲ್ ಇಟ್ ಆಸ್ ಎ ಲ್ಯಾಂಬ್ಡಾ ಇನ್ಫಿನಿಟಿ. ಇಲ್ಲಿ ನೀವು ಇದನ್ನ 1 1 1 ಅಂತ ನೀವು ಮಾಡಿ ಇಟ್ಕೊಂಡಿದ್ರೆ ಅದನ್ನ ಲ್ಯಾಂಬ್ಡಾ ಇನ್ಫಿನಿಟಿ ಅಂತ, ನ್ಯೂ ಬಾರ್ ಇನ್ಫಿನಿಟಿ ಆರ್ ಇಂಟು 1 ಅವರ್. ಸೊ 1 ಅವರ್ 1 ಸ್ಕ್ವೇರ್ minus 1 hour infinity square. And you know that this is the reciprocal, and 1 by lambda, this is 1 minus 1 by infinity is equal to 0. And therefore your 1 by lambda infinity is equal to r. Okay, which implies your lambda infinity is equal to 1 by r. Therefore lambda infinity is equal to 1 by r value is equal to 1.097 into 10 to the power of 7. You take the reciprocal, so you will get 0.911 into 10 to the power of -7 meter. So it is lambda infinity. Therefore your lambda infinity is equal to 911 angstroms. ಅರ್ಥ ಆಯ್ತಾ? Did you follow this? The question, find the longest and the shortest wavelength of the Balmer series. Okay? Longest wavelength ಯಾವ್ದಕ್ಕಿರುತ್ತೆ? lambda h alpha line. Shortest wavelength ಯಾವ್ದಿರುತ್ತೆ? lambda infinity. And what else he has given? He has given that your R value is 1.097 into 10 to the power of 7 per meter. Now you write the same thing. First line of Balmer series. First line of Balmer series. first line of the Balmer series, bracket ali H alpha has the longest wavelength. Okay? Therefore, your nu bar is equal to 1 by r into 1 over n1 square minus 1 over n2 square is the generalized formula. And now you apply for this, your nu H alpha is equal to r into 1 over. So, your longest wavelength means you have to put n1 is equal to 1 and n2 is equal to 2. Therefore, here what you write is, so now you write for the longest wavelength, you put H alpha line, you put n1 is equal to 2 and n2 is equal to 3. Then, what is your formula? Your formula is nu H alpha bar r into 1 over 1 by 2 square minus 1 over 3 square. Therefore, you have already 3r, it's the fourth time that you are writing this one. It is 1 by 4 minus 1 by 9. 1 by lambda H alpha is equal to r into, so that you know that it is equal to 5 by 36. Therefore, your lambda H alpha is equal to 36 by 5r. Okay? Ivaga, you substitute the values. Therefore, your lambda H alpha is equal to 36 by 5 into r is 1.097 into 10 to the power of 7. As I used to say, 36 by 5, 0.911 into 10 to the power of minus 7. That if you simplify, you will get 6.563 into 10 to the power of minus 7 meter. And therefore, your lambda H alpha is equal to, 6563 angstroms. This is the longest wavelength. Now what you have to do for the shortest wavelength? So you write, for the shortest wavelength, in Balmer series, electron has to jump from, for the shortest wavelength in the Balmer series, electron has to jump from n is equal to infinity to n is equal to 2 in Balmer series. Okay? In Balmer series. Gothirli chanage. Because what we are discussing is a Balmer series, which is n2, this is n1. Therefore, you are in the expression for this nu bar, you write infinity r into 1 over. So this is 2 square minus 1 over infinity square, which comes out to be 1 by lambda infinity is equal to r into 1 by 4 minus 0, because 1 by infinity is equal to 0, and that comes out to be equal to r by 4. Therefore, your lambda infinity is equal to 4 by r. That's equal to 4 by 4 into 1 by r, 1.097 into 10 to the power of 7. And therefore, your lambda infinity is equal to 4 into 0.911 into 10 to the power of minus 7. Okay? That you work it out. So therefore, your 4 into 0.911. Okay? That comes out to be 3.644. 3.644 into 10 to the power of minus 7 meter. Okay? Or your lambda infinity is equal to 3644 angstroms. ಚೆನ್ನಾಗಿ ಗೊತ್ತಿರಲಿ, infinity and actually it should be between 4,000 to 8,000 as for Balmer series, but 3,600 would be okay. Okay, this is very important for you. The next question is, find the longest and the shortest wavelength of the Paschen series. Okay, find the longest wavelength means it is the first line of the Paschen series. Okay, and the longest wavelength is from infinity given this R. ಏನು ಬರೀಬೇಕು? First line of the Paschen series has the longest wavelength. You write the generalized formula. You know that for the first line of the Paschen series, electron has to jump from 4 to 3. That is, you put N1 is equal to 3. So you put N1 is equal to 3 and N2 is equal to 4. Electron has to jump from 4 to 2. That's why you should remember the diagram. Now we have to work it out. So therefore, what is this value now? So therefore here the value will be 1 by 3 square, 1 by 4 square. That comes out to be 1 by 9 minus 1 by 16. And you know that this value would be 16 minus 9 is equal to 7 by 144. And therefore your lambda h alpha, so it is equal to, we call it as a lambda 1. We shall call it as a lambda 1 because, so we are now talking about not the Balmer series, we are now talking about the first line of the Paschen series. Therefore we write it as a lambda 1, therefore your new lambda 1 is equal to, it is 144 divided by 7R. This is the equation. Okay. Now you substitute the values. Therefore your lambda 1 is equal to, it is 144 divided by 7 into 1 by R value is 1.097 into 10 to the power of 7. As usual, you know that it is equal to 144 by 7 into 0.911 into 10 to the power of minus 7. So now you simplify that. So n martira, it is 144 divided by 7. Okay, multiplied by, so 0.911. And that comes out to be 18.74. 18.74 into 10 to the power of, so minus 7 meter. Okay, it is equal to, so 18.740. Okay, if I shift the decimal place, that comes out to be 18740 angstroms. See, look, this comes in the infrared region. Visible is from 4,000 to 8,000, visible region. Infrared region is from 8,000 to 20,000 angstroms. It is 8,000 to 20,000 angstroms. You know that it is in that region, therefore you should write that it is in the infrared region of the electromagnetic spectrum. Okay, it's the longest wavelength. You know, for the shortest wavelength, what you have to do? Electron has to jump from n is equal to infinity to n is equal to 3 for Paschen series. Remember. Therefore, this comes out to be n1 is equal by 3 square minus 1 by infinity. 1 by lambda infinity is equal to R into 1 by 9 minus 0. And that's equal to R by 9. Therefore, your lambda infinity is equal to 9 by R. Now, you substitute these values. Lambda infinity is equal to 9. 1 by R is 0.97. 1 by 10 to the power 7, which comes out to be 9 into 0.911 into 10 to the power of minus 7. And therefore, you calculate that value 0.911 into 9. That comes out to be 8.199 into 10 to the power of minus 7 meter. Therefore, 8199 angstroms. Remember, it's very important. Okay? ಯಾತಕ್ಕೆ ಸರ್ ಮಾಡಿದ್ರೆ ಇದು ಒಂದೇ ಥರ ಲೈಮನ್ ಬಾಮರ್ ಪ್ಯಾಷನ್, ಇದು ಇಂಪಾರ್ಟೆಂಟ್. ಇದು ಎಕ್ಸಾಮಿನೇಷನ್ ಬರುತ್ತೆ, ಸಾಮಾನ್ಯ ಕೇಳ್ತಾ ಇರ್ತಾರೆ ಇದನ್ನು, ಅದಕ್ಕೆ ಈ ಥರ ಮಾಡಿದೆ ಇದನ್ನು. ಗೊತ್ತಾಯ್ತಾ? ಸೊ ಅದರಿಂದ ಜ್ಞಾಪಕ ಆಗಲಿ. ಇದು ಈ ಲೈಮನ್ನು ಪ್ಯಾಷನ್ನು ಬ್ರಾಕೆಟ್ ಸೀರೀಸ್ ಮಾಡ್ಕೊಳ್ಳಿ. ಲೈಮನ್ನು ಬಾಮರು ಪ್ಯಾಷನ್ನು ನೀವು ಬೇಕಾದ್ರೆ ಮನೇಲಿ ಬ್ರಾಕೆಟ್ ಸೀರೀಸ್ ಬೇಕಾದ್ರೆ ರಿಪೀಟ್ ಮಾಡಿ. ಅರ್ಥ ಆಯ್ತಾ? ಓಕೆ, ನಾವು ವಿ ಶುಡ್ ಟರ್ನ್ ಟು ದ ನೆಕ್ಸ್ಟ್ ಕ್ವೆಶ್ಚನ್. ವಾಟ್ಸ್ ದ ಕ್ವೆಶ್ಚನ್? Given the longest wavelength of the Lyman series to be 1215 angstroms, calculate the shortest wavelength of the Paschen series. Given the longest wavelength of the Lyman series to be 1215 angstroms, find the shortest wavelength of the Paschen series. Okay. Given the longest wavelength of the Lyman series is 1215, find the shortest wavelength. Again, you write the formula, generalized formula, you don't forget. 1 by n1 square minus 1 by n2 square is the formula. Again, you write first line of Lyman series has the longest wavelength. For which you put your n1 is equal to 1 and n2 is equal to 2. Therefore, your new one is equal to r into 1 over 1 square minus 1 over 2 square, which is nothing but 1 by lambda 1 is equal to r into 1 minus 1 by 4 and 1 by lambda r into 3 by 4. Therefore, your lambda is equal to 4 by 3r. Now, it is equation number 1. Okay. Now you write for the shortest wavelength of the Paschen series. So the shortest wavelength of the put n1 is equal to 2 and n1 is equal to 3 for in Paschen series. For if you want to get the shortest wavelength. Therefore your formula is this. Now it is equation number 2. Okay. Now you want to calculate the shortest wavelength of the Paschen series. What you do is you divide equation 2 and 1. Lambda infinity by lambda 1. Lambda infinity is equal to 9 by r and that's equal to 4 by 3r. Where r get cancelled. Therefore, what you are going to get is equal to 9 by 4. This 3 comes to numerator. Therefore, your lambda infinity is equal to 27 by 4 into lambda 1. That is 27 by 4 into lambda 1 is equal to 1215 angstroms. Now you simplify that. That is, so your 27 divided by 4, that should be multiplied by 1215 angstroms, which is 8201. That comes out to be, so 8201 angstroms. Remember last time when it 81999 alva, almost 8199 and 8201 ಎರಡು ಆಲ್ಮೋಸ್ಟ್ ಆಲ್ ಸೇಮ್ ಇದೆ. ಅರ್ಥ ಆಯ್ತಾ? ಸೊ ಇದು ಚೆನ್ನಾಗಿ ಗೊತ್ತಿರಬೇಕು. ಇದು ಬಹಳ ಇಂಪಾರ್ಟೆಂಟ್ ವೆರೈಟಿ. ಹುಷಾರು, ಇದು ಇಂಪಾರ್ಟೆಂಟ್ ವೆರೈಟಿ. ನಿಮ್ಗೆ ಏನಾದ್ರು ಫಸ್ಟ್ ಲೈನ್ ಆದ ಪ್ಯಾಷನ್ ಸೀರೀಸ್ ಕೊಟ್ಬಿಟ್ಟು ವೇವ್ಲೆಂತ್ ಸೀರೀಸ್ ಲಿಮಿಟ್ ಆದ ಲೈಮನ್ ಸೀರೀಸ್ ಯಾವುದೇ ಕೇಳ್ಬೋದು. ಇದಿಷ್ಟು ವೆರೈಟೀಸ್ ಚೆನ್ನಾಗಿ ಗೊತ್ತಿರಬೇಕು. ಅರ್ಥ ಆಯ್ತಾ? ಯು ಟೇಕ್ ಅಪ್ ದ ಲಾಸ್ಟ್ ಪ್ರಾಬ್ಲಮ್ ನಂಬರ್ 8. ಗಿವನ್ ದ wavelength of H beta line of the Balmer series. He has given the wavelength of the Balmer series as 4861 angstroms. Find the shortest wavelength of the Lyman series. Okay. Again, you should write your generalized formula R into 1 over n1 square minus 1 over n2 square. Okay. ಅದಾದ್ಮೇಲೆ ಏನು ಬರೀತೀರಾ? Should write for the longest wavelength the wavelength of for the H beta line of Balmer series put n1 is equal to ಚೆನ್ನಾಗಿ ಜ್ಞಾಪಕ ಇರಲಿ, n1 is equal to 2 and n2 is equal to 4. ಜ್ಞಾಪಕ ಇದೆಯಾ? H beta line ಇಲ್ಲಿಂದ ಬರಬೇಕು 4 to 2 ಬರಬೇಕು, 4 to 2. ಓಕೆ, ಆವಾಗ ಇನ್ ಯುವರ್ ಫಾರ್ಮುಲಾ ನ್ಯೂ ಬಾರ್ H beta is equal to R into 1 over 2 square minus 1 over 4 square. 1 by lambda h beta is equal to r into 1 by 4 minus 1 by 16. As you know, it is 1 by lambda h beta is equal to r by 4 is a common factor. 1 minus 1 by 4 you are going to get, and that value would be r by 4 into 3 by 4. And therefore your 1 by lambda h beta is equal to, if you take the reciprocal, 16 by 3r, which you can take it as equation number 1. He ಕೇಳ್ತಾ ಇರೋದೇನು, shortest wavelength of the Lyman series. You know that for the shortest wavelength of the Lyman series, for the shortest wavelength of Lyman series, you put n1 is equal to 1 and n2 is equal to infinity, alva? Electron has to jump from infinity to one level. Therefore, in your formula, lambda infinity r into 1 over 1 square minus 1 over infinity square, and that new infinity is equal to r into 1 minus 0, because 1 by infinity square is infinity only, that's equal to 0. And therefore, your 1 by lambda infinity is equal to r, which implies lambda infinity is equal to 1 by r. If you substitute that is equal to 1 by r, you take it as equation number 2. What do you want to calculate? You want to calculate the shortest wavelength of the Lyman series, lambda infinity. Therefore, you do divide equation 2 and 1. Divide equation 2 and 1. Therefore, your lambda infinity by lambda h beta is equal to 1 by r, and that value is equal to 16 by 3r. Your r get cancelled, it is 3 by 16. Therefore, your lambda infinity is equal to 3 by 16 into lambda h beta. So 3 by 16, lambda h beta is given to be 4861 angstroms. So you simplify these two. So it is 4861, and you are dividing by 16, then you are multiplying by 3. That comes out to be 911, which comes out to be 911 angstroms. Okay? ಅರ್ಥ ಆಯ್ತಾ ಪ್ರಾಬ್ಲಮ್ ಇದು? ಇಷ್ಟು ಪ್ರಾಬ್ಲಮ್ನ ನೀವು ಕರೆಕ್ಟಾಗಿ ನೋಡ್ಕೊಳ್ಳಿ, ಆಯ್ತಾ? ಇಷ್ಟು ಪ್ರಾಬ್ಲಮ್ನ ಕರೆಕ್ಟಾಗಿ ನೋಡ್ಕೊಳ್ಳಿ.